today's session. So basically, last class we were trying to understand what is the motivation behind studying this numerical methods, and what is the difference between the analytical techniques and the numerical techniques. We were trying to understand that. In that, we had discussed about different types of solutions. Like when we had learned mathematics in our school level, we had learned that addition of two numbers like 2 plus 2 will give you 4, which is a exact solution. Like we can definitely say that yes, the answer to this problem is 4. However, when we find the square root of a particular number, or the fractional power of any particular number, we cannot. Those numbers are basically irrational numbers. Like square root of 2, we basically say it is 1.414, or square root of 3 it is 1.732. But however, these are not exact numbers. Like there are infinite digits after the decimal point, and these are known as the irrational numbers. So these are this we are trying to approximate. So this is the basic difference. First, we need to which we need to understand before we move into the numerical methods. The difference between the approximate solution and an exact solution. And so why we want to find numerical, why we want to solve any equation by a numerical method? There are different analytical techniques present to solve any kind of the normal equations. Like if we have an equation like this, x square minus 4 equals to 0, we know the exact solutions of these two equations, which is minus 2 and 2. So this is an exact solution. Whereas if I have an equation like x square minus 3 equals to 0, it gives me two different solutions again. These are minus root 3 and plus root 3. These are also exact solutions, but we need to understand here there is a small difference between this exact solution and the previous one which I described. So here we don't know what is the value of exactly the value of root 3. We can either uh, just a second. Just a second. People are entering now. Everyone kindly mute your mics. If you want to say anything, you can unmute and speak. Okay, so that's what I was telling. Like x equals to, if we get two solutions like plus minus root 3, it is not an exact solution. It is an approximate solution, because the value of x, we can either report it after rounding it off up to a particular digits after the decimal point. Like if we want to round off x to 3 digits after the decimal point, we can write it as minus 1.732. However, that is not the exact solution. Yes, Atikur, you want to say anything?
Sorry, sir.
Please mute yourself. If you want to say anything, you can always unmute and let me know. Okay. Okay. So this is the basic difference between which we need to understand between an exact solution and an approximate solution. So this kind of equations, like the normal algebraic equations, the polynomial equations, this can be solved using your normal analytical techniques like the factorization technique which we are using here. However, if we have some equations which are known as transcendental equations, like a combination of an algebraic and a logarithmic term, or a combination of an algebraic and a trigonometric term. So those kind of equations, we directly cannot find a solution using our standard analytical technique. Like this equation you can see here, x square minus cos x equals to 0, or x minus log x equals to 0. We don't have a direct analytical technique to solve these kind of equations. And in order to find a solution for these equations, we cannot get maybe an exact solution for these equations, obviously. However, we can try to approximate the value of x, the solution for x for these kind of equations, and we need to use numerical methods for that. So this is the basic motivation behind our numerical methods. And we all know that you might ask that what is the use of these transcendental equations? All over any engineering problem or any kind of mathematical physical problem, if you think of any system which you can think of, obviously you have to represent that system in terms of some mathematical equations which we need to solve and find the solution to that particular problem. And all real life problems, these are defined by different nonlinear complex equations which we cannot solve using our normal analytical techniques. In order to get a solution for that, we need to use our numerical methods, where we basically at the first step, the basic crux of any numerical method is we basically assume an initial solution, and we gradually, based on some iterative techniques, we gradually approach towards that exact solution. So this kind of methods are known as numerical methods. So we will see here how we can not only solving an equation by numerical method. Obviously, root finding is one of the main topics in numerical methods. Then we will be having our normal numerical differentiation, numerical integration. How can we integrate a function? Like, we always don't have an exact formula for an integration for all kinds of function. So how to integrate those functions? We can have a complex function, and we need to, maybe to find a solution for that, we need to integrate that particular function. So we don't have an analytical technique for that. So basically, then we will be using the numerical methods. So then moving forward, we looked at the first numerical technique, which is known as the Hennon's algorithm. So it is a basic technique to find the fractional power of a particular number. So first we tried to find the square root of a particular number, which was so here basically x square equals, we are trying to find the square root of a number. That is, we are trying to approximate under root n by a numerical technique. You have a technique for finding the square root of a square root of a particular function by repeated divisions. However, here we will not be using that. We will be using our numerical technique, or an algorithm which has been proposed by a scientist named as Hennen. So you can see here, based on small manipulations, we arrived at this formula, which is highlighted in red here. That is, x nu equals to half into x plus n by x. This is the simplified iterative formula for finding the square root of a particular number. And any numerical method or an iterative method, we have to perform several iterations. And every step we have to check the tolerance. That is the difference between the previous value and the value at the current step. Here I have done up to 4 iterations here. So you can see here, at the first iteration will always start from 0. That is, I equals to 0 for the first iteration, and x of I, the initial value, this has to be supplied in the question. This will be given to you. Based on an initial value, you will be approaching towards the solution. So x of 0 was equals to 1. And here you can see the formula is half into x plus n by x. N is basically 5 here. We are trying to find the square root of 5. That's why our n value is equal to 5. So we have made two columns for x1 and n by x1. And then we will be adding those and divide by 2 to get the value of x new. So xi is 1, x 5 by xi is 5, and x new is 3. So this 3 which we obtained at the end of the 0th step will be your value for x of I at the next step. Okay. Like this, we will move forward. Again, 3 x of 1 is 3, 5 by 3 is 1.666. Again, we find out x new 2.333. This 2.333 will come in as the value in the next step. So like this, we will move. Now you might ask, how many times do I need to perform this iteration? So your tolerance will be given in the question. Like, tolerance here is given as 0.0001. So what does this tolerance mean? The basic meaning of tolerance here is actually, at every step when you calculate this value of x new, you have to find the difference between the value at the present step and the value at the previous step. That is, at the first step I'm getting as 2.33, previous step I got as 3. So the difference here is zero point 0.7, and you have to divide, and you have to find the percentage difference. So once that percentage difference is less than or equal to this tolerance value, then we basically stop the iteration. So a more crude way of telling, or a simple way of telling this is, if the tolerance is 0.001, that is 10 power minus 3, you need to check the value of x new in the two consecutive iterations. If the 3 digits after the decimal place are same, then you can stop your iteration. Like in the fourth step, I obtained 2.236, whereas in the third step it is 2.237. That means the first 2 digits are same in both the iterations. However, the third digit is still not same. So one more step we need to do, one or few more steps we need to do. Still, these 3 digits are almost the same. Is this concept clear? Any doubts? Anyone?
No, sir.
Okay. So similar to this, in order to find the kth root of a particular number, like the third root, fourth root, fifth root, if you want to find out, I have done a simple derivation which you can go through, and this is my iterative formula, which is x nu equals to x into k minus 1 by k plus n by k into x to the power k minus 1. So basically here, if you substitute k equals to 2 in this equation, you will get back to this equation which we derived in the last formula, that is half into x plus n by x. Similarly here also, you can obviously I have not done it by code. By MATLAB code I explained you how to formulate this in MATLAB and how to find out the error at every step. You can just go through the recording. Okay, so this was all about Henon's algorithm. Then we move to the Taylor series. So what is basically Taylor series? Taylor series is basically to approximate the value of a function at a particular point, right? So suppose you have a function, just imagine like this. You have a function f of x equals to sine of x, and you want to find the value of sine x at x equals to 0.75. So this is the formula, that is f of x naught plus h equals to f of x naught plus h into f dash x naught plus h square by 2 factorial f double dash x naught h cube by 3 factorial f triple dash x naught. So basically what we do here is, for the sake of easiness of calculation, we ignore the terms from the second derivative onwards. Okay, we ignore the term from second derivative onwards and we take only the first two terms. And all the terms which are in the after the first derivative, those are termed as the error terms. So now we will see here how we can approximate the value of sine x at x equals to 0.75 using the Taylor series. And h will be given in the question. H is here 0.25 and x is 0.75. So in how many steps we will be? First we have to find the number of steps, which is given by x by h. That is, x is our target value and h is the step value. So you need to go to 0.75 from 0 in steps of 0.25. So like this you have to go. First is 0, then it is 0.25, then you have to find 0.5, then we'll move to 0.75. So like this we will move in 3 steps. Okay. So at every step you have to apply this formula, the formula for Taylor series. So first step x naught is 0. So first step x naught is 0, h is 0.25, and you need, what the formula is, f of x naught plus h equals to f of x naught plus h into f dash x naught, right? So basically you need f dash x also. So f of x is sine x, f dash x is cos x, right? And x naught is, for the first step it is 0 and h is 0.25. We substitute this and we get the value of sine 0.25. Then we move to the second step. In the second step, your x naught will be, it was 0 in the first step, so it is 0 plus h in the next step. So it is 0.25 and h is 0.25. So then we find out, first step we found out sine of 0.25. Second step we'll find out sine of 0.5. We obtained. Step 3, x naught is 0.5 and h is 0.25. So we'll get x naught plus h is 0.75. So we are finding sine 0.75 here, which is 0.7097. However, if you use your calculator and try to find out what is the exact value of sine 0.75, it is a bit different. So it is 0.6816. So it is 0.6816. So you can see here that there is a considerable difference between these. I also explained why this difference is coming. It is because of the step size. We are using a discrete step size, right? So the more you reduce the value of h, that is more number of computational steps if you involve, then your error will reduce. And I showed this using your MATLAB code. And I also gave you a homework for that, for which some of you have submitted the homework. Okay, fine. So any doubts, any questions? Yes, Atikur, you want to say something? You have raised your hand.
Yes, sir. Sir,
Yes.
you can tell find the kth root of any number, but
Hmm.
in MATLAB code you use absolute term. Sir, if the number is complex, then the root is not the absolute number.
I could not get you. Can you tell once again?
Yes, sir. Sir, in Taylor series, you tell
Hmm.
us kth root of any number. That number could have been
No,
a
in
complex
Taylor
number.
series, I did not describe about root of any number. It was in Hennon's algorithm.
Ji, sir. But sir, we can't use absolute term in MATLAB because if the number is complex, then the error or anything that will be not absolute term. Sir, you did
You
not
can
get
tell me
it?
in Bengali. You can tell me in Bangla what you are trying to tell.
স্যার আপনি আসলে আহ,
Hmm.
বলেছিলেন যে হচ্ছে মানে kth root of any number তারপর
Hmm.
ম্যাথল্যাব প্রোগ্রামে টলারেন্সের ওইখানে আবার ইউজ করছেন অ্যাবসোলিউট টার্ম।
1 minute. I'll share the screen. You just tell me where you are facing the problem. Just a second.
স্যার স্কোয়ার রুট লাইন নাম্বার 20।
Just a minute. Which code you are talking about?
স্যার
Hennon's
হেনন্স
algorithm or
জি
Hennon's?
জি স্যার হেনন্স
Hmm. Line number?
20।
Line number 20. I have not used absolute term anywhere here.
স্যার
Okay, this one you are telling tall. Abs
জি
of
স্যার
this one, right?
জি স্যার
Yeah. So what is your doubt here? X you are telling if it is a complex number.
ইয়েস।
So why you will get a complex number? I'm trying to find the nth root of a natural number. How can you find the nth root of a complex number means what you are trying to tell? Is it a imaginary term you are trying to tell or something else?
ইয়েস স্যার ইমাজিনারি টার্ম।
How will you get imaginary term? This is only for finding the root of a this real number, not for it is not applicable for any complex number or anything.
ওকে স্যার।
This algorithm is only for finding the square root of the kth root of any real number. Not it doesn't involve any imaginary number here.
থ্যাংক ইউ স্যার।
Anyone else? Any other doubt?
So what about the Taylor series expansion for a multivariate function?
That is yes, that I can discuss, but currently with the course as I have designed, that I have not included actually. That is a bit advanced level for like after we go to the single variable thing, we can obviously we can look into the multivariable thing, but I have not included that. If you want, I can obviously discuss in the next class. I can discuss.
Sure, sure.
Is
Yeah,
the Yeah,
thanks.
it is the same thing. Just we'll have two variables here, x and y. We can obviously discuss. Any other questions? Anyone? Okay, so I'll move to today's class. Okay, so today first topic which we will be seeing is it has to be covered in the first class only. I missed it. Just a small topic. It is uh, your you know about the different number systems, right? One is the decimal number system, then you have the binary number system, and then you have your octal number system or your hexadecimal number system. So how to convert between these different number systems, so that we will be discussing. So it is a very small topic. I'll just finish it off quickly. So there are basically four number systems are there. First is your decimal number system, which we use in most of our mathematical computations. Then you have your binary number system, and then we have our octal number system, and lastly we have the hexadecimal number system. So we'll learn how to convert between these number systems. Can you tell me what are the digits? How many digits are there in your decimal number system? Anyone?
Sir, 10.
So it is from 0 to 9, right? We have 10 digits, and we'll be using these 10 digits in different combinations to represent our number. So in binary number system, how many digits are there?
Two.
It
0,
is
1.
0, 0 and 1, right? In octal,
0 to
0 to
7.
7.
0 to 7. And in hexadecimal,
0 to 15.
0 to 15.
into 15.
yeah, it is not actually 0 to 15. It is the 0 to 9 and A to F, right? So these are the different number systems. So I'll be describing, mostly I'll be limiting myself to decimal and binary number system. Octal and hexadecimal, it is, you can just look into it. So first we will try to learn how to convert a binary number to a decimal number, or rather the opposite one first we'll learn. How to convert a decimal number to a binary number. Suppose you have your decimal number given, you have say 139. So any decimal number we will be representing like this to the base 10, because there are 10 digits. So we'll be representing it in brackets subscript 10. So you have to find out the corresponding binary number to the binary number. Two digits are there. So basically 2, right? So first try to understand what is the process. So when we convert to decimal to binary, we have to divide the number by 2. Repeated divisions we have to carry out. So if we divide 139 by 2, so it is basically the quotient is 69 and the remainder is 1. So we'll be writing like this. Again we will be dividing. So it is 34, 1. Again if we divide by 2, it is 17 and 0. 8, 1, 4, 0. So until this quotient becomes 0, you have to continue the division. Okay. So now you need to just represent this number in the reverse order. In this order. So 139 to the base 10 is equals to 0. We don't need to write 1, 0, 0 like this. 1 in the reverse order. So it is 1, 0, 1, 000, then 1, 0, 1, 1 to the base 2. You can add this 0 here. So this is your corresponding binary number. Is this process clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So now your homework here will be to write a MATLAB code for this. So just note down the question. So it will be write a MATLAB code to convert a decimal number to a binary, to its corresponding binary. So your code should take a decimal number as an input and it should give the output as the corresponding binary number. Okay. Now the reverse thing we will see how to convert a decimal number to a binary number. The reverse one, sorry, binary to decimal. So if we see how to find out the binary to decimal, yes, Javed, you want to say anything?
Sorry, sir. As far I know, I think there is a MATLAB pre-built syntax to convert binary to decimal or decimal to binary. But why we are using numerical methods? As
This
you
is not
said,
numerical method. This has nothing to do with numerical methods. This is just a technique. MATLAB has everything. If you want to, this Taylor series, Hennon's algorithm, whatever we wrote the codes, MATLAB has inbuilt functions for those. But you need to understand the physics behind it or the mathematics behind it, right? That's why we are learning all these things. So whatever we will learn afterwards, the numerical integration, numerical differentiation, everything, trapezoidal rule, everything, MATLAB has an inbuilt toolbox for that. But
yes, sir.
we will not be using that.
Thank you, sir.
Okay. So if we want to convert your binary number to a decimal number, suppose you have, I'll just convert this same number. So it is 1000101. 1001011. So this is your binary number. You have to find the corresponding decimal number. Right. So what we do is we first write the number and then we assign place values. Here it is. This is the from the right we will start. The first digit will be numbered at 0, then 1, 2, 3, 4, 5, 6, 7. Then what we will do is every digit, that is the seventh digit here, is 1. So it is 1 into 2 power 7. So why 2? Because the base of the number is 2. There are two digits in binary number. And so the base of a binary number is always 2. Whereas there are 10 digits in the decimal number. So the base of any decimal number is always 10. So zeros we don't need to consider, right? Again, 1 we have at third place. So it is 1 into 2 power 3 plus again 1 we have at first place, 1 into 2 power 0. So 2 power 7 is how much? 128 plus 8 plus 2 plus 1. So it gives me 139. So you saw that in the last exercise we converted 139 to the corresponding binary number. Again here we converted that same binary number to the corresponding decimal number and it gave me 139. So that means our process is correct. Both ways we have checked it. Is this process clear? The algorithm?
Yes, sir.
So here also you have to, for the homework, you have to write a MATLAB, you should write a MATLAB code. Write a MATLAB code to convert a binary number Fine. Is the question clear? Your input here should be a binary number and output should be the corresponding decimal number. Fine, clear? Any doubts about the homework? You can ask me anytime or anything of which I have discussed so far. Any doubts?
No, sir.
Okay, fine. So this part has nothing, this number systems and all what I discussed. Yes, Javed, you want to say something?
Sir, then we should follow the pre-filtered syntax method, or we should use the loop that will divide the number till we got 0 or something like that. That means I
No, no.
am,
Two approaches you described, right? First is what you told.
sir, pre-built syntax there to convert
No.
decimal to binary or
Don't
decimal.
use pre-built syntax. Don't use pre-built syntax. If you
Okay, sir,
use
that's the
pre-built
question, sir.
syntax, then that is of no use. This is just for learning purpose. I'm giving this so that you are much more familiar in MATLAB. That's why I'm giving you these exercises. If you use the pre-built techniques, so that basically totally disturbs the purpose of the question, right?
Yes, sir.
One line
Yes,
you
sir.
can obviously write directly. We have the commands to convert from binary to decimal or decimal to binary in MATLAB.
Okay, sir.
You have to loop the number. You have to create either a for loop or a while loop, and then you have to solve the problem.
Yes, sir. For clarification, I am just asking.
Yeah, understood. Thank you.
Thank you, sir.
Any other doubts? Anyone? Okay, fine. So this has nothing to do with the numerical techniques. Just this is a basic you can tell before starting about the numerical techniques. We just discussed about this systems. Okay. So now we will see into one more topic, which is called as error analysis. So before we go into any numerical technique, how do we know that our numerical technique is accurate? Right? How do we know our numerical technique is accurate? So for that, actually, we have to compare our results with the actual solution of that particular equation, right? So there are two kinds of errors. Errors can be quantified as in two types. First is your absolute error, and next is your relative error. So what is the difference between this absolute error and relative error? So suppose there is a say an X numerical technique you have used and you have found the solution of your problem to be P star. Okay, this is the solution obtained, and you know the exact solution of that problem as say P. So suppose you have, so P star is the obtained solution using numerical technique, and P is the exact solution to the equation. So your absolute error here will be modulus of P minus P star. So this is your absolute error. Okay. And what is your relative error? Relative error is your absolute error mod of P minus P star divided by P. So this is your relative error. So I'll just give an example. Suppose the exact solution to the equation is 2. Suppose the exact solution is say x equals 2. And from the numerical technique, you have obtained your x as say 2.23. So you can see here that your exact solution and your obtained solution are not the same. So for any numerical technique, it is there. So what is your absolute error here? It is 0.23. So this actually the relative error here, if you calculate, it is 0.23 by 2. So if you want to express it in percentage, just multiply it by 100%. So it will be around 0.11, right? So it is around 11%, approximately 11%. So you can understand here that the absolute error does not give you a perfect picture of whether your solution is accurate or not. It is a relative error. Obviously, every time we should find the relative error, because the relative error actually compares your. Hello?
ও আচ্ছা, কি ভাই বলেন?
Fahim, kindly mute your mic.
এটা তো আমি করি নাই, এটা ওই কারা করছে অনেক টনে কদের দিকে তো ছিলাম না।
Hello, Fahim. Please mute everyone. This is a request. Please mute your mic when I'm talking. You can raise your hand and you can ask me anything if you want. Okay. So the relative error actually, it compares your error, the value of the error with the actual solution. So that gives you a better idea or a better picture of the quantification of the error, because here you can understand your relative error is 11%. So I'll give you another example. Suppose using a numerical technique x1 and there is a numerical technique x2. Okay. So here I'm telling here the obtained value is say 2.23 and your actual value is say 2. So your absolute error is 0.23 and your relative error is, as we found out, it is approximately equal to 11%. So suppose there is another numerical technique which gives you your obtained value as say 1.23 and your exact value is say 1. So what is the absolute error? It is again 0.23. However, the relative error here is around 23%. So if you just compare the absolute error of these two problems, you can see here that it will seem to you that both the errors are same, because absolute error value, it is 0.23 for both the methods. So actually the absolute error conveys a negative meaning, because although your absolute error is same, so you cannot conclude that both these techniques have given you the same accuracy level of the solution, because relative error is 11% for the first case and relative error is 23% for the second case. So that basically gives you an idea that your first method is more accurate than your second method. But if you compare the absolute error, it will give you an idea that both the methods are equally efficient or gives me an equal accuracy. But that is not the case. So I described this because I wanted to quantify I wanted to emphasize on the fact that relative error is more important in case of, as far as numerical methods are concerned, than the absolute error. Fine, is it clear?
Yes, sir.
Okay. So we'll look into a simple problem with this. So the question goes like, suppose P star is the solution. It must approximate P with the relative error at most 10 power minus 3. Find the largest interval in which P star must lie for P equals to 100. So anyone can try to solve this problem. First, you need to understand what it is telling. So it is telling that suppose P star must approximate P with relative error at most 10 power minus 3. So your relative error is given as 10 to the power minus 3. So then it is asking in the question, find the largest interval in which P star must lie for P equals to 100. So your P is given as 100, right? You have to find P star. And it is not a single value, remember.
So P star would be P plus minus 0.1.
Yes, correct. P plus minus 0.1. So I'll just describe for the students how we can find out. Uh, okay, so P equals to 100 is given and P star, they have asked in the question to find the interval, right? So how can you find the interval? Any suggestions, anyone from the students? How can you go about to solve this problem? Any idea? Any idea on how we can go about to solve this problem? I can solve the problem, but you should also get involved. Otherwise, so can someone tell me what is the formula for the relative error? Just now I described what is relative error in terms of P and P star. Any idea? I just now described, right? Javed, can you tell?
So the formula was, I think, P star minus P by P into 100%.
Yes, you are correct. But one thing you missed, it is modulus is there, right?
Yes, sir.
So this modulus actually means that either it can be more, that P star can be more than 100 or less than 100. Both we are taking here. So that actually gives me the range for P. It is called in the question it is asked find the largest interval, right? So modulus of P star minus 100 equals to P is 100 into 10 power minus 3. So modulus of P star minus 100 equals to 0.1. So from this, can you tell me what is the interval for P star? Anyone? How to solve this equation? Modulus of P star minus 100 equals to 0.1. Yes, Javed?
Sir, is it 100 plus minus 0.1? That means
Yes.
99.9 to 100.1.
Yes, correct. You're absolutely correct. So good. So basically from here we can
Thank
write
you,
P
sir.
star minus 100 equals to plus minus 0.1. So P star will be 99.9. That is, it will be included. The interval is P star is 99.9 to 100.1. So if the value of P star is in between these two numbers, that is 99.9 to 100.1, your error, that is your relative error, will be maximum 0.001. Or it will be less than that. So that was the question, right? Clear? Any doubts, anyone?
No, sir.
Sir.
Yes, sir.
Fine. So now we will be moving to um, a new concept today, that is the matrix form of equations, right? Up till now, whatever I have discussed, it's clear, right, for everyone?
Yes, sir.
Okay. So we will be looking into how to solve an equation using the matrix approach. So before we go into this, we need to understand few things. So can you tell me what is the general equation of a straight line?
Ax plus bx plus c.
Yes.
Ax plus bx plus c.
Can you be a bit louder? I could not hear you.
So the general form is ax plus bx plus c is equal to 0.
Ax plus bx plus c. So a straight line
Sir,
has
I think
generally
it's
two. Yeah, Javed.
sir, I think it's y is equal to mx plus c.
Yeah, y equals to mx plus c. Or what the other person also described, it is correct. He missed the term. It is ax plus by plus c equals to 0. Either way, you can express it. Either it is y equals to mx plus c or ax plus by plus c equals to 0. Both are correct. Okay. So now you know how to plot a straight line equation in our graph. So suppose I'm just starting from the very basic level. So uh, if anyone might feel bored, but just bear with me for a few moments because mostly these are students from BTech background. So I need to tell them about the basics first. Then I'll be moving to the things. Okay. So suppose you have this straight line equation, right? Y equals to mx plus c. So what is m here? M is the slope of the line and c is the y-intercept, right? So how do you plot this line? So there are many methods by which we can plot a line, but what I use, I'll describe you. Suppose you have an equation like this, 2x plus 4y equals to 8. So what I do is I always convert this equation into this form. X by a plus y by b equals to 1. If I convert it into this form, then in this graph, this a and b will be my x and y intercepts. Suppose I can plot the line like this. It will pass through a comma 0 and 0 comma b. So similarly, if I try to do it for this equation, it will be this right hand side I have to make it 1. So it is basically x by 4 plus y by 2 equals to 1. So my equation, the plot of the equation will look something like this. Your x-intercept will be 4 and y-intercept will be 2. So this is my 4 comma 0 and this point is 0 comma 2. So this is the basic way to solve an equation. Clear, right?
Yes, sir.
Okay. So now if I tell you how to solve an equation, suppose there are two variables, x and y. So if there are two unknowns, you will need to have two equations in order to solve that. Suppose this is my first equation and say another equation is 2x plus 4y equals to 8 and one more equation if I say x plus 3y equals to 9. This is my another equation. And so the equations are 2x plus 4y equals to 8. So that basically boils down to x plus 2y equals to 4. That is my first equation. And next equation is x plus 3y equals to 9. This is my second equation. So you can obviously use the elimination technique and you can solve this. But I will show you a technique by what is the graphical approach, how to interpret it graphically. So you will understand better. Second, draw in the next page. So the equations are x plus 2y equals to 4 and x plus 3y equals to 9, right? So first one is if I express it like this, x plus 4 y by 2 equals to 1, and this will be x by 9 plus y by 3 equals to 1. So first equation I'll try to plot here, which is x by 4, right? So if I just approximately, if I discretize this 1, 2, this is 9, say around here it will be 4, x by 4 and y by 2. So this is my line 1, and my line 2 is x by 9 plus y by 3, right? Here approximately if it is 3. So here if I try to solve these equations, it will be y equals to 5 and x plus 15 equals to 9. X will be minus. So the intersection point is minus. So if I try to plot this equation, it may not be accurate. It will be something like this. So the line will be passing like this. So this is my line 2 and this is my first line. So what is the solution you obtain? It is minus 6 comma 5. So graphically how you can obtain the solution? It is the intersection point of the two lines. That is the solution of that particular equation. So it is basically minus 6 comma 5. The plot is not exact. I'll show you in your in the MATLAB just now. So this is the basic thing for a 2D equation. That is our line, a straight line is a 2D equation. So I described this because I want to go to the 3D thing. First, I need to understand in order to explain the 3D equation, I need to first explain you the 2D thing. That's why I went through it in a faster manner. Is it clear to you? Any doubts?
No, sir.
No, sir.
Okay. So now if we try to move to the, just a second. Okay. So now this was about the straight line equations, right? So now if we try to move to the 3D equations, so can you tell me like ax plus by equals to c, that represents a straight line, right? So what does this equation represent? 3D equations. So if we have ax plus by plus, say, a third term is there, plus cz equals to d. What is the geometric interpretation? What is the geometric plot of this equation? Any idea, anyone?
Hi, Samadip. I think this is the question for the plane.
Yeah, correct, Raj. So this is the equation for a 3D plane, right? So it is difficult to draw in this pen and paper. I'll show you what a plane looks like. What is the equation of the plane from the MATLAB plot here. Okay, just for visual, I'll just share my screen. Yes, Raj, can you mute yourself?
Yeah, sure, sure.
Is my screen visible? Is the screen visible? Can someone confirm?
Not yet.
No, sir, not yet, sir.
Oh, okay. 1 second. Now,
Yes, sir.
okay, fine. Thank you. So here you can see, I'll just show you first, then I'll explain the code. Okay. So here what we are basically trying to do, we are trying to we are trying to visualize a plane. Okay. So 1 second. So here the equation of this Z1 I am trying to plot, which is 6 minus x minus 2y by 3. Okay, here I'll describe you. So Z I am writing 6 minus x minus 2 into y by 3, right? So what I'm trying to explain here is you have an equation, say ax plus by plus cz equals to d. So if you want to plot it, if you want to plot and see what is the equation of the how the plane looks like. So basically what you have to do is you have to first in the first line 3 and line 4, what I have done is I have selected a panel of x, that is I want my x to be between minus 10 and 10, and this middle 1 means x will be an array from minus 10 to 10 with an increment of 1. Y similarly I am choosing as minus 10 to 10 with an increment of 1. And what this mesh grid command does is mesh grid actually creates a mesh that is if I run this code, I'll show you just a second. So if I just look into what is x and what is y, you can see here. So x you can see first x and 1 second, just a second. This x1 and y1 I have taken from minus 10 to 10, and y1 is from also from minus 10 to 10. So x this small in line 7 what I have used is I have created a mesh using this x1 and y1. So x and y here basically it gives you a mesh, that is x you can see here. This is a matrix of 21 into 21 size, and it is minus 10, that is the lowest limit on the first column, and then minus 9 in the second column, third column minus 8, minus 7, minus 6, like this it goes on till 10. So you have 21 columns and also similarly 21 rows. So x and y also you will see y will be just the opposite. Y is a this 1 into 21 size. So if you just see what is x of 1, it is minus 10, and y of 1 is minus 10. So basically from if you just imagine, just try to imagine a mesh of x varying from minus 10 to 10 and y varying from minus 10 to 10. So you can imagine how many points will be there. There will be 21 into 21 points. So basically 441 points in that mesh. And that I am trying to create by x1 and y1 using the mesh grid command. This mesh grid command is inbuilt in MATLAB, which helps you create a mesh. So now once you have x and y, the meshes, you need to find out the corresponding z. You have the equation, right? Ax plus by plus cz equals to d. You have x and y, just substitute in place of x and y and find out what is z in terms of x and y. So I have an equation which gives me this z1 is equal to 6 minus x minus 2y upon 3. So that gives me my z. Now just forget z2 and z3 for now. Then in line 15, we have this figure of surf of Z1. So surf command is basically used to plot the surface. That is a plane 3D surface. In order to plot that, we use the surf command. Okay. So now if I see the result of this, so you can see here, this is a 3D plane. I can rotate it and show you. Can you see the plane?
Sir. Yes, sir.
You can see, right? So this is a plane, you can understand. So I'll mark the axis also. So this is my x-axis. This is my y-axis. And this is my z-axis. So you can see here the plane, right? So it is not possible to draw it in the in a 2D paper, pen and paper, because it is a 3D figure. So here you can in MATLAB you can obviously see the plane. You can see here the mesh. If I just try to find what is the corresponding x and y. See, this is the xy projection. That is the plane in the xy plane. So here I'm trying to, now the z is increasing. You can just rotate it like this and you can see what is the plane. Clear?
So can you explain this mesh grid concept again? What is
Yeah,
mesh
mesh
grid?
grid I'll explain. Yes, I'll explain. Just give me a few moments. I'll just finish this and I'll write and I'll show how it is working. So now if I want to plot another plane in this, Z2 is the equation of another plane and Z3 is another plane. Obviously, you can understand that the intersection of two planes will give you a straight line. It will not give you a point. Just remember this. The equation of the intersection of two planes, it gives you a line, not a point. Like the two intersection of two straight line gives you a point. The intersection of two planes, it gives you a straight line. However, the intersection of three planes, if you try to understand, that will give you a point, either if solution exists, obviously. So now, like Z1, Z2 is another plane. So here I have just figured surf of Z1. Hold on means in the same figure, the plot will be plotted. So first plane will be plotted. Then I am asking computer to hold on. Hold on means just hold on. Then I'll plot another surf of Z2. Just see this one. So here you can see two planes, right? So if you see this, you can try to understand that there are two planes here and the intersection also you can see. See, the intersection is a line. Are you able to understand this? Are you able to visualize this thing?
Yes, sir.
Everyone?
Yes, sir.
Yes, sir.
So that you can see here and visualize that the intersection of two planes is a straight line. Now, if I plot the third plane also, what will happen? This might be a bit difficult to visualize. So you can see here three planes are there. And the intersection point, it's difficult to understand. It is a point, but it is difficult to understand, obviously. Is the code clear? Any line of the mesh grid, I'll obviously explain. Any other line of the code which is not which you are not able to understand? You can, if you have any problem, you can tell me here in the code. No doubts, right?
Yes, sir.
Yes, sir.
Yes.
Now I'll explain this mesh grid command. Just a second. Okay. So anyone understood what is the mesh grid command? Someone asked me a doubt. Sir, you asked about the mesh grid command. Can you tell me your name? I could not get your name, sir.
Yeah, so you can call me RK Goyal. So my name is RK Goyal. Yeah.
Okay, okay,
You can
Mr.
call
Goel.
me. Yeah. Yeah.
Okay, okay, fine. Okay, sir. Anyone has anyone understood about the mesh grid command? What is it? Any idea? Or you have used the command previously?
No, sir.
You don't know what is the mesh grid command, right?
So create a mesh.
Hmm. Can you explain how it is being created? Yes, Jamilur, you want to say something?
But I can make a guess. I can make a
Yeah,
prediction.
yeah, sure, sir.
So like say we have been given say X as a collection of the points, say x1 say till xk, and y is given as a collection of the points, say y1 and say till ym, then this masquerade probably showing the points like x1 y1 x1 y2 and then x1 say till xm, and similarly x2 y1, and then so basically the Cartesian
Yes.
product of x and y, I guess.
Yeah, correct, exactly. That is what the mesh grid command is doing. I'll just show you here. Suppose I'll take a small value. Okay, say x is from 0, 1, 2, 3, 4, 5, and your y is also the same. I'm taking 0, 1, 3, 4, 5. So now I want to plot a mesh using this value of x and y, right? So before going to the mesh grid command, just try to visualize this. You have the x and y coordinates here. So x is 0, 1, 2, 3, 4, and 5. Similarly, you have also 5, 4, 3, 2. It is not exactly correct. 1. So now if I want to create a plane with this, a mesh basically, so I need to include all these points, right? It is 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0. This all, whatever I'm marking with blue, I have to include all these things. So this interior points also. So all these red marked and blue marked points. So what mesh grid does is, if I supply it with this x and y array, it will in a different x and y array, it will give me all the coordinates, the x and y coordinates of all these points. So if I write capital X, capital Y equals to mesh grid of x and y, what will x will be 5, right? Here. 1, 1, 1, 1, 1. 4, 4, 4, 4. Similarly, 5, 5, 5, 5. And similarly, so what is the first point? It is 0, 0. So y should be 0, 1, 2, 3. 1 second, just a second. Uh, just a second. So basically, so y will be basically 0, 0. So this will be my output of the mesh grid command. So now if you carefully look into what is this first value is 0 here, first value is 0. That is the first point, 0, 0. Now next point is 1, 0, right? If we move in the horizontal direction. So it is, you keep the this one 1, 0. Second value is 2, 0. 3, 0, 4, 0. Like that, if I combine x and y, I'll get all the points in the particular mesh. Is it clear?
So actually, these capital X and capital Y's, I mean, these are not clear. So what is the outcome of applying the masquerade function? What are we getting here?
We are getting basically x and y as the this x and y has two different matrices which basically contains all the points in that particular mesh. Now if we want to plot a surface, say I have an equation like this: ax plus by plus cz equals to d. From this I have created a mesh. I have the x data in my x matrix, y data in my y matrix. Then using this equation, I will find what is my c, like d minus ax minus by by c. So that's what exactly what I have done in the in the previous in the code. I have created a mesh of x and y, and then we are finding out z in terms of x and y. For each point, it will evaluate the value of z, and then using the surf command, it will basically plot x, y, and z.
So I mean, I could not understand the construction of the Y matrix here. All zeros one side, all ones. Then why
Yeah, may
so?
I
I
see,
mean,
sir?
why this moment?
Uh, Sorry, I didn't get your question. So if you
So my question,
combine this x and y matrix, you will, like, if you fix the first row x in the x matrix, if you fix the first row 0 1 2 3 4 5, right? If we combine each of the elements with each of the values in y, you will get a particular point.
oh yes, now I understood. Yeah, thanks. It's clear to
Yeah,
me now.
yeah.
Yes.
Yes, Dr.
So,
Srimonti.
Yes, sir.
Yes,
What I
ma'am.
think that when we are calculating this capital X matrix, that
Hmm,
for each and every variation of small y, what are
hmm,
the values of x that is being written here? Like when small y is equal to 0, that
hmm,
time x
hmm.
values is 0, 1, 2, 3, 4, 5. So we'll put
Yes,
it in the first row. And
yes, yes.
second, when again small y is equal to 1, y is varying when you are calculating capital X. So for
Yes, ma'am.
every other values of small y, we'll
Hmm.
write down the values of x in every other rows.
Yes,
And the
yes,
same
correct.
thing will happen in case of capital Y. When you are
Hmm,
calculating capital Y for every other values of small x,
hmm,
see if we check when small x is equal to 0,
hmm,
the y values are 0. So we are putting it on the first row.
hmm.
So for the second row, again, the next variable is x is equal to 1. That time,
Yes.
all the values are 1. And that's why this is how I think the matrix has been created.
Yes, yes, correct. That is another way of obviously visualizing the same thing. Yes, you are
so
correct.
yeah, so yes, Amit, I'd like to add one thing. Like
Yeah,
here
yeah.
we can see basically we can understand it this way also that X is the transpose of Y or vice versa. So uh, the structure of matrix can
Uh,
be understood in that way also.
yeah,
Can we say that?
you get obviously, yes, correct.
Yeah, because X is completely transpose of Y or Y is
Yes,
transpose
yes,
of X. In that way
correct.
also we can
Yes,
transpose it.
Raj, you are correct.
Yeah, yeah.
Transposition is possible because the values, the matrix are same in both the cases, x, small x
Yeah,
and
yeah.
small y.
Yes,
But
yes,
the
correct.
case
Because
is
X,
Yeah.
different in that case. Yeah,
Mhm.
we can't do that.
yeah, if the
Yeah,
size,
yeah, yeah,
obviously, if the values are different in Y
Mhm.
and X,
Mhm.
obviously it will not
Mhm.
be transposed. You're correct.
Yeah, correct, correct. Because of the
Yes.
same values, we are able to do the transpose.
Hmm.
So is it the thing if values will be same
No, no,
anytime we
no.
do the
Anything you
masquerade or
can
it
take.
can
Anything. Based on small
anything we
x
can
and
take? No?
small
Yeah,
y, the
yeah,
x
yeah,
and
yeah,
y matrix
yeah,
will
yeah,
be
yeah.
created.
Will be created. Entries can be anything.
Yeah, yeah. It can be anything.
Okay, sure.
Okay. Dr. Ajinka, you have posted some error is coming for you. Yeah, Dr. Ajinka, you want to say something?
Hello. Yeah, hi.
Yes, sir. Yes, sir.
I tried to. Oh, you can call me Ajinkya. No worries.
No, no, I
So
am PhD student. Okay, fine, sir.
yeah. So I tried to work this out on the MATLAB, but
Hmm.
certainly it's giving me an error on line 7, which has this square bracket xy equals to mesh grid x1 y1. I don't understand why it is giving me the error. I'm trying to work on it, but
Hmm. Okay, okay. Just a second. I'll just the same thing what I did.
yes, 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 yes. I'm working on the same thing what you have written on your MATLAB.
Okay, just a second, sir. I think execution of script mesh grid as a function is not supported. Just a second.
So yeah,
Let me
all the
check once.
codes I've written in the third box.
Hmm.
So I don't know if you could debug and let me know
I
where
will
I'm
check that
getting
one.
wrong.
X1 and Y1. I'll just remove my this one. This.
Yeah. Yeah, for square brackets, it was giving like, unnecessary. So I removed that out.
No, that is not creating problem. It is giving for me without the square bracket also. Maybe I think you are using which version of MATLAB?
I'm using, this is an academic use of
Okay. Actually, I
2023.
understood what is the problem. What you have named the function as mesh grid, is it?
Yeah,
No, you cannot use that because mesh grid is a keyword, right? It is a
right.
reserved keyword for MATLAB. You cannot use that as the name of the function. When you save the function, save it with some other name.
Okay. Okay.
I
Okay.
think that is creating the problem because mesh grid is a command. No, you cannot use the function name same as the any command.
Uh-huh.
Like you have plot command in MATLAB, right? So you cannot
Yeah,
use those commands directly as the name of the function, name of the script file.
right. Right.
Just check once with by changing the name, and you can tell me. I think the problem will be solved.
Sure, sure, sure. Thanks, thanks.
Yeah. Yes, Srimanti madam, your any error message you are facing?
No, sir. All okay from my
Okay.
side.
Okay. Fine. Thank you. Okay, so this was about the visualizing of the plane, 3D equation in your MATLAB. Through MATLAB, you can visualize. Now we will quickly move to one of the methods to solve this. Yes, Remia, you want to say something? Yes, Dr. Remia, you want to say something? Madam, you are not audible. Hello, you are not audible, ma'am. No, you are not audible. Your mic is on, but you are not audible. You can just type in the chat section. Maybe some problem with your mic. Yes, you can type in the chat section your query. Okay, so you're asking how the color grading of the mesh grid can be changed. Okay, color grading means okay, the color of the plane you are telling whatever color I'm getting, you want to get a different color. That has to be changed from the settings most probably. I'm not sure of that. I think it has to be changed from the some MATLAB settings, some plot. Yes, correct. In the MATLAB, when you plot it in the plot window, you will have some color toolbar or something like that. From there, you have to change the color settings. Some RGB color is present. You have to change the color code of that. Is it fine? Anything else you would want to ask, ma'am? Okay. Anyone else? Any other doubt? Any other doubt? Anyone?
No, sir.
No, sir.
Okay. Okay. So now we will move to a technique of solving this linear equations, which is known as Gauss elimination. Uh, all of you are familiar with what is a Gauss elimination technique?
No,
Are
sir.
you you have not studied Gauss elimination? You're in which year of BTech?
They are from third year.
Okay, I think they should. Did they learn about Gauss elimination in their mathematics course?
Sir, I learned it's about image processing. That is row and column reduction type something.
Yes, yes, correct, correct. Yes, that is used in image processing also, correct. Okay, so we'll see here how we can solve. Suppose there are three equations, right? So in order to solve an equation with n unknowns, you have to have n equations, right? If you have n unknowns, you need to have n equations in order to obtain a solution. So say the first equation I'm writing x so these are the three equations which we need to solve. Okay, so you have different techniques for obviously solving these equations. You can use elimination technique. You can multiply first equation by 7, then you can eliminate one variable. That all are there. Those are the there. But here I am trying to teach you about the Gaussian elimination technique. So what is the first step in Gaussian elimination technique? We need to form the matrices first. So the first matrix is my coefficient matrix, which is named as 1. So it will basically contain the coefficients of the variables, like coefficient of x is 1, y is 2, z is 1, then 2, 3, 4, 3, 5, 7. This is A is called the coefficient matrix and B is your RHS matrix or the source matrix. So it will be the right hand side, 8, 20 and 34. Fine. So now in Gaussian elimination, what you have to do is basically you have to reduce this coefficient. No, first you have to form the augmented matrix. Okay. What is my augmented matrix? It is A slash B. So it is given as 1, 2, 1. First you write down what is there in A matrix. Just in the last column, you add the B matrix also. So that basically gives you your augmented matrix. Is it clear? Any doubts?
No, sir.
This is my augmented matrix. Okay. So now your duty here will be to reduce this augmented matrix. Reduce augmented matrix to an upper triangular matrix. Do you have any idea of what is an upper triangular matrix and what is a lower triangular matrix? Anyone?
Sir, I think from first, um, sir, I don't know the name, but I can write it. Or
Means you know what
sir,
is an
this is,
upper triangular matrix and what is a lower
yes, sir, yes,
triangular
sir,
matrix.
yes,
You
sir.
right, you know, right? Okay. Yes, madam, you're telling something.
Yeah, upper triangular means when actually this is the division made by these diagonal parts, diagonal elements. Huh.
Yes.
So in upper triangular matrix, all the elements, the off diagonal elements, upper
Hmm.
of the diagonal part is non-zero value.
Yes, yes, correct.
And in lower triangular matrix, that's the opposite. That is all the non-diagonal elements
Hmm.
above the diagonal elements are zero.
Yes, yes, correct.
So
So are
actually,
they
I've been missing
yes.
the diagonal word.
Okay, okay, fine, fine. All of them are familiar, madam, with this upper triangular, lower triangular matrix, or should I describe it?
Please describe, sir, because they are
Okay,
not
okay,
familiar with this one.
okay, 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 fine. So an upper triangular matrix is of this form. It is basically So this is 0, this is 0, this is 0. For a 3x3 matrix, I am obviously describing. So what is your principal diagonal here? This is your principal diagonal, right? So if this is your principal diagonal, anything above this principal diagonal, that is these elements. Just a second. This element, and this element, this will be non-zero. All elements in the principal diagonal and all elements above the principal diagonal will be non-zero. Anything apart from this, that is anything below the diagonal, the principal diagonal element, principal diagonal will be 0 for an upper triangular matrix. So I'll write it here. All elements below the upper diagonal are 0. Now, what is a lower triangular matrix? Just the opposite. Anything. So it is basically L11, 0, 0. This will be 0. L21, L22, L31, L32, L33. So this is my lower diagonal matrix, lower triangular matrix rather. So again here, this is my principal diagonal. Anything below it will be non-zero and anything above it will be 0. All elements above the upper diagonal all elements above the upper diagonal are 0. Right? Is it clear the difference between lower triangular and upper triangular matrix, everyone? If
Yes, sir.
only it is clear, then I can move forward. Otherwise, you will not understand. Clear, right?
Yes, sir.
Okay. Now I'll go back to the problem which I was describing. So I'll write my augmented matrix first, right? So what is my augmented matrix? So it is 1, 2, 1, 8, 2, 3, 4, 20, 3, 5, 7, 30. So first step is we have to convert this augmented matrix to an upper diagonal matrix. So if we have to convert this matrix to an upper diagonal matrix, that what does that mean? This element, and this element has to be 0. Okay. So if our objective here will be to make all these 3 elements to 0. So how we can do that? Any idea on how we can do that? So we have to do what is called as row operations and column operations. Yes,
Sir,
Javed.
row echelon method or something like that.
Row echelon method we have to use, and we have to perform the different row operations, and we have to make all these elements 0. So we'll just see how we will be doing it. So first is this 2, 1 element, that is this element we have to make it equal to 0. So if I want to make it equal to 0, so if I do this, the second row, that is R2, equals to R2 minus 2R1. 1 second. M into R1. So what should be this M? M will be A21 by A11, which is 2 by 1. That is So basically, you have to perform this operation. R2 equals to R2 minus 2R1 in all the elements of the second row. So now what will be my A slash B matrix? So it is 1, 2, 1, 8. So this first element will be 0. 2 minus 2 into 1, right? It is 0. 3 minus 2 into 2, that is 3 minus 4 is minus 1. 4 minus 2 is 2. 20 minus 16 is 4. And 3. I'm doing it step by step. Okay. Now the next target, this one we have made it 0. So the next target is this element, we have to make it equal to 0, right? So if I want to make it equal to 0, what I should do? With the first row I have to exchange, right? So step 2. R3 will be equal to R3 minus M into R1. What is M here? M is A31 by A11. That is 3 by 1 equal to 3. So R3 will be R3 minus 3 R1. Is it clear? Any step you are not following, please stop me. 1, 2, 1, 8, 0, minus 1, 2, 4. So now R3 is equal to R3 minus 3 R1, right? So 3 minus 3 into 1 is 0. 5 minus 3 into 2 is minus 1. 7 minus 3 is 4. 34 minus 24 is 10. Okay. Now two steps are done. The next step is this one we have to make equal to 0. Is it clear? The two steps are, you tell me what will be the next step. I'm writing here. Tell me what will be R3 here. Yes. Javed, can you tell?
Sir, R3 minus R4. Or
Where is R4 here? R4 means the fourth row. Is there any fourth row here?
sorry, R2 minus. Sorry, sir. R2 minus R2 minus R3.
Yes. So R3 is basically R3 minus R2. Right?
Yes, sir.
So then this element
Yes,
will
sir.
be 0. So A slash B, can you tell me what will be the new matrix, the third row? Yeah.
Sir,
So can you
0,
tell
0.
me? 0,
Sir,
0.
0, 0. Minus 2 minus.
Is it minus 2
Sorry,
or
sir.
2? I
0,
have done
0. Sir,
2 and 6.
2, 6.
Yes.
Yes, sir.
So, yes. So now your goal is fulfilled. This one is 0. This one is 0. This one is 0. It's done. Now your Gauss elimination is done. Now what you have to do is back substitution. Now we have to do back substitution. So how to do back substitution? So what is my matrix now? A slash B is 1, 2, 1, 8, 0, minus 1, 2, 1, 8, 0, minus 1, minus 1, 2, 4, 0, 0, 0. So back substitution means we have to go in the backward direction. That is from the bottom to the top in order to find the solution. This is backwards. So you know there are three variables, right? So here you can see you have there were three equations, right? It is x, y, and z. You have to basically find the values of x, y, and z. So from the last row, what you can see, the first column corresponds to x, second column corresponds to y, third column corresponds to z. And this last column 846, that is basically your RHS. So from the third row, what equation can you write in terms of x, y, and z? The coefficients of x and y are 0, you can see in the last column, right? Only z coefficient is there. So you can write z into 2. So it is basically 2z equals to 6. From this you can get z equals to 3. From the second row, what is the equation you can write? Anyone can tell?
Minus y plus 2z equal to 4.
Minus y plus 2z equals to 4. Now you know z is equal to 3. So minus y plus 6 equals to 4. Y will be equals to 2. So one equation and from the first row, what you can write? X plus 2y
So x plus
plus
2y.
plus z equals to 8, right? So you can substitute y and z here. It is x plus 4 plus 3 equals to 8. So your x is 1. So these are the solutions. The unknown matrix is 1, 2, 3. So this is the total process of solving by Gaussian elimination and back substitution. So first you have to reduce your matrix to a upper diagonal matrix. Then we have to use the back substitution in order to solve this equation. Is this total algorithm clear to you?
Can you explain this back substitution again? How did you get these
Yeah,
values?
yeah, sure. So after the Gaussian elimination, we have this augmented matrix, right? 1, 2, 1, 8, 0, minus 1, 2, 4, and 0, 0, 2, 6. So your first column, it corresponds to the first unknown variable, which is x. The second column corresponds to the second unknown variable, which is y, and third column corresponds to z. And this one corresponds the last column, that is your RHS matrix, right? So from the third row, if you see, so your third row is 0, 0, 2, 6. So x coefficient is 0. So it is x into 0. If we try to reconstruct the equation from the matrix, it is x into 0 plus y into 0 plus 2 into z equals to 6. So that basically gives me z equals to 3. Similarly, for the second row, it is 0 into x minus y plus 2z equals to 4. From that, you know z from the last step. You can find out y. And here, the first row, all the coefficients are there. So it is x plus 2y plus z equals to 8. You substitute y and z from the previous step, you can get value of x. So this is your solution, the unknown matrix, the solution
Yes,
to
yes,
these
clear.
equations.
Yeah, clear. Thanks. Yeah.
Yeah, thank you. Any other doubts, anyone?
No, sir.
Clear, right?
Yes, sir.
Okay. Okay, so today we will stop the class here. So homeworks you have noted, right? I have given 2 homeworks, and the MATLAB code for this Gaussian elimination, it is a bit difficult, so I'll not give it as homework. I plan to show it to you today only, but time is not permitting. So we'll do it in the next class. I've written the code. I'll explain you and I'll show you how to do all this Gaussian elimination in MATLAB. So the 2 homeworks you please try out, and you try to. I'll send you a Google form. There you have to upload by before next Tuesday. Before next Friday, sorry. Fine. Any clarifications? Anything? Otherwise, I'll stop for today.
Fine with me. Fine.
Okay. Anyone else? Anything? Any clarifications?
No, sir, clear.
Okay. Fine. Okay, then we'll meet next Friday, 6:30 in the evening.
Thank you so very much. Great session. Bye.
Thank you.
Thank you. Thank you.
Thank you, Samarisha.
Yeah.
Thank
You
you so
can.
much.
Yeah. Thank you.